we assume that these are the things which people can do it on their own, and that is nothing but having fundamental definition or the understanding of numbers. For example, what is integer, then what is I would say prime numbers, what are rational numbers, etc., etc., right? So I believe these are very very elementary things, so I'll be skipping those things. I'll directly come down to prime numbers and perfect numbers. So today's sessions I'll be focusing mainly on prime numbers, and obviously if time permits then definitely we'll go to the perfect squares also, because these are the two different or these are the two, I would say, topics within number system wherein variety of questions have already appeared in CAT or CAT like exams. So a basic understanding about prime number is very very important, and I believe that all of us are well aware about the prime numbers, that these are the numbers which are divisible by either themselves or one, right? So we can say that 2 is a prime number, then 3 is a prime number, then 5 is a prime number, so on and so forth. So the very important thing which we have to understand is that from 2 to or from 1 to 100 there are 25 prime numbers, and I believe all of us can write down all those prime numbers, and please remember those numbers also. Just for a caution, I can just tell you that 91 is not a prime number. Many a time student gives me this answer that 91 is a prime number. 91 is a multiple of 13 and 7, so it's not a prime number, right? Apart from 2, all other prime numbers are even are odd numbers. 2 is the only even prime number and is the smallest prime number, I would say, and that makes this number very very important whenever questions comes from the area of prime number. Correct? Now there are other things which we need to understand about prime number, and that is that all the prime number which are greater than 3, all the prime number which are greater than 3 can be written in the form of 6k plus 1 or 6k minus 1. So these are the forms in which all the prime numbers can be written, but the converse is not true. So let me explain it in detail. When I say a prime number, say 23, this is a prime number, so I can write this as 6 into 4 minus 1, right? That means this can be written in the form of 6k minus 1. And if I want to find, say, or if I want to write, say, 31, say, then 31 can be written as 6 into 5 plus of 1. So we can say that all the prime numbers can be written in the form of 6k plus 1 or 6k minus 1, but the converse is not true. What do I mean by that? I mean to say that all those numbers which are in the form of 6k minus 1 or 6k plus 1 or 6k plus 1 need not necessarily be a prime. For example, if I take 25, so 25 can be written as 6 into 4 plus 1, right? This can be written in the form of 6k plus 1, but it's not a prime number. So always remember that all prime numbers are in this form, greater than 3 obviously, are all the prime number greater than 3 are in these two forms, or we can say that all the number in this form need not necessarily be prime number. Now why do we learn these things? This is very important to solve certain kind of questions which have appeared in CAT. So I have directly taken those questions, so we'll be taking those questions in some time, wherein we have to ensure that no numbers in the form of 6k plus 1 or 6k minus 1 agrees with that particular conditions, right? Guys, please in between do response to whenever I say anything, right? So that I'll come to know that my voice is audible to all of us. Is this part clear, that the prime number are in the form of 6k plus 1 or 6k minus 1? Of course, many of you might be interested in the derivation of it or the logic behind it. So, but the purpose of this session is not to derive it, because that thing has already been done in my online course. Each of the concepts or theorems have been derived appropriately. So whosoever has enrolled for it, obviously they can go and identify that why all prime numbers can be written in the form of 6k plus 1 or 6k minus 1. Correct? So these are the two things which we have to remember in as far as prime number is concerned. And there is one more thing which we have to keep in mind, that there is no formula to generate prime numbers, right? There is no formula derived till now which can generate prime numbers. This we have to always remember. So whenever you come across a question and you feel like that this question, by putting the values, say 1, 2, 3, 4, etc., every time it is generating a prime number, it is not always that that formula will generate prime number for all the natural number. Now let me give you an example for it. If I take, say, or if I ask a question, so let me just write the question here. Suppose say small n is a natural number, and if I say that capital N can be written as n square plus n plus 41, right? And if I ask you to comment about capital N, whether it's a prime number or it's a composite number, I'll just take a pause for some time. Please respond in the chat whether it's a prime number or a composite number. Yes guys, only one answer, prime number. Okay, so those of you who are saying prime number, they have not understood the concept or the things which I told you to remember, that there is no formula to generate prime number. अभी बताया था ना कि कोई भी फॉर्मूला नहीं है अभी तक जिससे प्राइम नंबर जनरेट हो सकता है. एंड इफ यू से दैट इट्स अ प्राइम नंबर, देन व्हाट यू आर एक्चुअली डूइंग इज दैट, व्हिच obviously most of us will do, is that we start putting the value of n to be say 1 2 3 etc, right? So the moment we put this value, and if I want to find the value of n, then every time you'll be getting a prime number for the initial few values. For example, for small n is equal to 1, you'll be getting it 43, which is a prime number. For n is equal to 2, it will be 4 plus 2, that is 6 plus 41, that is 47, again it's a prime number. For 3 also you'll be getting a prime number, and for 4 also you'll be getting a prime number. But if I put the value of n to be say 41, will it still be a prime number? Will n still be a prime number? I'm just waiting for your answers. अभी नहीं होगा ना प्राइम नंबर, right? So you have understood, you are understanding this concept, right? Because there is no formula to generate prime number. This is a temporary formula, I would say. It will give prime number for initial few values, but it will never give prime number for all the values or for all the natural numbers. So do keep these things in your mind. Whenever you find any question wherein for initial some value it gives a prime number, do not jump into a conclusion that it's a prime number, right? It may be a trap. Okay, so these are the 3-4 things which are very very necessary for understanding the concept of prime number. Let me, without wasting the time, directly come down to the concept of, or the questions based on the concept of prime number. So let me take the very first question. And this is the first question, which says that if x square minus y square is 101, then we have to find the value of x square plus y square given that x and y are natural number. Now this is a very easy question. Without wasting time, what we can do here is that we can factorize it, right? We can say that x square minus y square can be written as x minus y and x plus y, correct? Now if this is equal to 101, now the important thing about 101 is that it's a prime number, right? Now, how do we ensure that a number is a prime number if it is not the smaller sum prime number? Then there is a method to test whether a number is prime or not. What we do is that, for example, here we can take that 101. The very first thing what we do is that we take the under root of it and we try to find the closest value. So obviously, if had it been 100, the value would have been 10. So we can take a number more than 10. So let me assume it to be 11. Then what we have to do is that we have to take all the prime numbers starting from 2 till 11. So all the prime numbers starting from 2 till 11 is this, right? And taking each of these number and we try to find out if it is divisible, if the number 101 is divisible by any one of them. So we can see that 101 being odd will not be divisible by 2. Divisibility by 3, we know that the sum of the number has to be divisible by 3. So this is not divisible by 3. In fact, it is not divisible by 5, and we can check that it is not divisible by 7, neither with 11. And if it happens that it is not divisible by any of those prime numbers which we have taken less than this number, then we can be very sure that this number is a prime number, right? So here 101 is a prime number, and it can be written as per the given condition, x minus y into x plus y. So obviously this I can say, if I take x and y to be any natural number, this will be one of the number and this will be another number. Since it's a prime number and it can be written as a product of two natural numbers, then the only possibility is that it has to be written as 1 into 101, right? There is no other way of writing it because 101 is a prime number. Had it been some other number, then we would have got a multiple cases. So from here we can say that since x and y are natural number, then x minus y would be less than x plus y, right? Because both are positive number. So if I compare term wise, so we can say that x minus y has to be 1 and x plus y has to be 101. So we can solve these two equations to get the corresponding value of x and y. So therein if I add them, then we'll get 2 of x is equal to 102 and the value of x will be 51. And if I substitute the value of x to be 51, then the value of y would be 50. So we have got the value of 51, x and y as 51 and 50. So we can get the answer to be 51 square plus 50 square. Whatever it comes would be my answer. Correct? I'm not just going into the calculation part. I believe this much is understood. Now, such is the kind of questions wherein we have to apply the very fundamental things of prime numbers. Correct? I believe every one of you must have understood it. Let me move to the next question. Okay, now this question has appeared in CAT. Already it has appeared in CAT. I'll take a pause for a couple of minutes. Please give me the answer for this. Please try and give me the answer for this. Answers, anyone? Okay, only one value. Let me just give you the logic to solve this question. Now it says that p plus 2 and p plus 4 are prime numbers. Then we have to find that how many value p can take. So here p is a prime number, right? So we have to only take prime numbers. And we have to take p as prime number such that all three values, that is p plus 2 and p plus 4, all three have to be a prime number, right? So how to approach such kind of question? The very first thing what we have to do is that we have to check for the base, the initial few prime number, and those are 2, 3, 5, etc. Right? At least check for the first two prime numbers. So if I take p to be 2, suppose if I take p to be 2, then p plus 2 and p plus 4, if I want to find, then this will be 2, this will be 4, and this will be 6. So obviously all three are not prime numbers. So we can say that p is equal to 2 is not my one of the solution. Now if I take p is equal to 3, then what will happen? Then it will be 3, this will be 5, and this will be 7. Now here we can see that all three are prime numbers, right? So if all three are prime number, then we can say that p is equal to 3 is one of my solution. Now for all other prime number, because there are infinite prime numbers, then how do I ensure that I have checked for all the prime numbers? So then you can take two approaches here. The first approach is that we can say that these are consecutive three numbers, right? Three consecutive numbers. Not consecutive obviously, but three consecutive terms of an arithmetic progression, I would say, right? So we can apply the logic of that. If I take three consecutive arithmetic number when the difference is 2, then one of the number has to be multiple of 3. So that is one of the concept which I'll come on to, which we'll discuss later on when we'll discuss the sequences. Let us discuss the other method, and that is, let us assume that all prime number which are in the form of 6k minus 1, because we have studied that any number which is greater than 3, any prime number which is greater than 3 can be written in the form of 6k minus 1 or 6k plus 1. So let us check all those prime number which are in the form of 6k minus 1. So if I substitute p to be 6k minus 1, then this value would be 6k minus 1. This will be 6k minus 1 plus 2, so it will become 6k plus 1. And this will become 6k minus 1 plus 4 will become 3. Now here we can see that these two may be prime number, but this can definitely be not a prime number, because I can take 3 common, right? Here I can take it as 3 into 2k plus 1. Now if I can write this as 3 into 2k plus 1, that means this can be factorized in other numbers other than the prime number, and 1. Here I can say that 3 is the factor of p plus 4. So we can say that p plus 4 will never be a prime number if I take p to be 6k minus 1, right? That means all such prime number which are in this form will not be my answer, or will not be the part of the solution. Now let us also check for p is equal to 6k plus 1. So the moment I take 6k plus 1, then p will be 6k plus 1. This will be 6k plus 2, 6k plus 1 plus of 2. So it will be 6k plus 3. And this will be 6k plus 5. Again we can see that this can further be written as 3 into 6k plus 1, right? Again we can say that now in this case p plus 2 will be the factor, or 3 will be the factor of p plus 2. Or we can say that all 3 will not be a prime number if I take any prime number which is in the form of 6k plus 1. So from here we can say that even if I take any prime number greater than 3, it will be in the form of either this or that, and in both the cases we can say that not all 3 will be a prime number, and hence we can conclude that there is only one prime number p which is equal to 3, for which all 3 numbers are prime numbers. So this is how we conclude, right? So we can say that confidently 100% we can say that the answer for this question is 1, and that is for p is equal to 3. Please remember that the question is asking about for how many values. It is not asking for which value of p, right? Many times we do these silly mistakes that we mark 3. The answer is 1, because it is asking how many values, not the value of p. Correct? I believe this much is understood. Now let me invite you to the next question. Again, I'll give you a couple of minutes to solve it. Now again, very similar kind of question do appear both in mocks and CAT exams. Please take them. I'll be taking 2 minutes pause. Okay. Now let's see how to solve this. Again, we'll be applying the similar concept which we did for the last question, right? So here we again have to find for how many prime number p this thing is also a prime number. So what we have to do is that we have to start substituting the value of p to be 2, then for 3. So we have to check for 2 and 3. So if I put the value of p to be 2 here, then p square plus 3 of p minus 1, it will be 2 square plus 3 into 2 minus of 1, right? Which is nothing but 4 plus 6 minus of 1, which is how much? 9. So we can say that this is not a prime number, correct? Now if I take p is equal to 3, then it will be 3 square plus 3 into 3 minus of 1, which comes out to be 9 plus 9 minus 1, which is nothing but 17. Now 17 is a prime number, so again we can say that for p is equal to 3, we are getting a prime number. So obviously the answer can't be 0, it has to be at least 1. Now again the same thing happens, that for how long I can check. So again what we have to do is that we have to check for p which are in the form of 6k minus 1 and which are in the form of 6k plus 1. So if I substitute from 6k minus 1, then p square will be 6k minus 1 whole square plus 3 times of 6k minus 1 minus of 1, right? Again if I want to expand it, then it will be 36k square minus of 12k plus 1 plus of, this will become 3 times of, so it will become 18k minus of 3 minus of 1. Now here we can say that minus 1 and plus 1 can be cancelled out, and each of these terms, if you observe it closely, they are multiple of 3, right? So here I can take 3 common. So here I will be left with, it will be 12k square minus 12k plus, this will be 4 and this will be 6k minus of 1, right? So again we can write this number p square plus 3p minus 1 in this form, or I can say that 3 will be the factor of this. So again if 3 is a factor, then we can say that this will not be a prime number, or we can say that all the prime number which are in the form of 6k minus 1 will not be giving this expression as also prime. Similarly, we can check for all prime number which are in the form of 6k plus 1. Again we'll be getting the same thing. So let me just do it for you. So it will be 6k plus 1 whole square plus of 3 times of 6k plus 1 minus of 1. Again if I open it, then it will be 36k square plus 12k plus of 1 plus of, this will be 18k plus of 3 minus of 1. So again we can cancel it out. Again we can see that all these terms are multiple of 3. So we can take 3 common and rest of the things can be put here. So again 3 will be the factor of this number, so, or this particular expression. So here again now we can conclude that no other prime number other than 3 will give me this expression to be a prime. So again the answer for this question would be 1. Right? So you can see that both these questions were of a similar kind. The only thing what we have to ensure is that we should be applying these two logics always, just to ensure that the answer which we are getting is always correct. Right? This is the learning from these two questions. So whenever we come across any questions related to prime number, try to apply these two logics. Correct, guys? Now let me move to the next question. Okay, I'll give you 2 minutes. Please solve. And guys, if you have any doubts, do let me know in the chat. I'll discuss it that also. Okay, any answers, guys? Again, we have to find for how many value of p we can take, or how many prime numbers are between these two numbers. No one? Okay. Okay, let me discuss this. Now this appear to be a difficult question, but it's actually not. Now for such kind of question, what you should be doing is that you should take one of the possible number. What could be the least possible number of p here? It has to be greater than this, right? And p is also a natural number. Every prime number is a natural number. So I can say that the smallest value which p can take is 2018 factorial plus of 2, right? Now we all know that this number is nothing but what 2018 into 2017, so and so forth, right? This thing is nothing but 2018 into 2017 into 2016, etc., etc., till the last number like this, right? And plus we are taking it plus 2. Now just observe that, can we take 2 common from this expression? I can write this as 2 into 2018 into 2017, etc., etc., till 3 into 1 plus of 1, right? So we can say that p can be written as 2 into this, or I can say that this is a factor of 2, or 2 is a factor of p. So if 2 is a factor of p, then definitely p cannot be a prime number, right? So we can say that the smallest possible number which p can take in this condition is not a prime number. Now if I want to take the next number, then it has to be 2018 factorial plus of 3. Now this again we can say that we can take out 3 common, because this is a multiple of 3, right? This number is a multiple of 3. So we can take 3 common, and rest of the things, something like that, will come down here. So again we can say that if p is equal to this, then this is a multiple of 3. So again p will not be a prime number. And if I extend this logic, then the last number which I can take, that is 2018 factorial plus 2017, then again we can say that 2017 is included in both of these terms. So this can be written as 2017 into 2018 plus of 1. Again we can say that this can be factorized, or p can be factorized as 2 natural number. And if it can be factorized in 2 natural number other than 1 and number itself, then it's not a prime number. So we can say that right from the smallest till the largest, every time we'll be getting the number x, which will be common in both the terms, right? The plus of x may be, and obviously in 2018 also, because this number x will always be less than 2018. So we can say that in none of the cases the number p will be a prime number, or we can say that the answer for this question is 0, right? Any doubt, guys? Because this is a very critical question. I'll just take a pause. Please let me know in the chat whether you have understood it or not. Okay. Okay, fine. Please, okay, let me just move to the next question now. So again, I'll give you 2 minutes to solve this question. Question number 5. And Chanpreet, what you can do is that take up any number between 2018 plus 1 and 2018 factorial plus 2018, right? Take up any number, and you'll find that the other number which you'll be taking is already present in 2018 factorial. So you can take it common. When I say common, that means that will be a multiple of that number, and a prime number cannot be multiple of any number other than 1 and itself. So we can conclude that it's not a prime number. ठीक है? Now this is another very important type of questions which I've asked in CAT exams. Okay, I'm I'm getting some answers. Okay, let's solve this. Now here it says that for how many positive integer n this expression is a prime number. So the very first thing what we have to do is that we have to factorize this, right? We have to use the method of quadratic equation to factorize it. And it is quite obvious that 24 can be written as 12 into 2, and we know that 12 plus 2 is 14. So we can straight away say that n square minus 14n plus 24 can be written as n minus 2 into n minus 12. Correct, guys? Now this, as per question, says that it has to be a prime number, right? Now again we see that prime number, if it is written in the as a product of two number, because whatever value of n I take, it will be a product of two number, that is n minus 2 and n minus 12. Now if a prime number, suppose example, if I take 17 and I want to write 17 as a product of two numbers, then the only way I can write it as either 1 into 17, or I can write it as minus 1 into minus 17. Correct? These are the only two ways I can write it. Fine. So what we can see here is that one of these two has to be either 1 or minus 1. Right? So let us start with this. So if I assume that n minus 2 to be equal to 1, then the corresponding value of 1 has to be, corresponding value of n has to be 3. Now let us try to put the value of n is equal to 3 in this expression and try to find the value. So here we can see that this will be 1, and the value of n we got it as 3. So it will be 3 minus 12. Right? It will be a negative number, and no negative number is a prime number. So we have to discard that. Right? Now if I take the value of n minus 2 to be minus 1, then the value of n has to be minus 1 plus of 2, which comes out to be 1. Now if I substitute the value of n to be 1, then it will be 1 minus of 2, that is minus of 1, into here it would be minus of 11, I believe, right? So it comes out to be 11. So here we can see that although these two numbers are negative, but we are getting as a product as 11, and the value of n is 1, which is a positive integer. So can I say this would be the answer? Now guys, I'll just want your responses. I'm just taking a pause here. Please respond whether you have understood this or not, because this is very, very critical. People usually skip the negative values. Right? Okay, great. Now similarly what we have to do is that we have to take the other factor. So I'll assume that n minus 12 to be equal to 1. Thereby I'll be getting the value of n to be 11. Now let me substitute the value of n to be 11 here. So if I substitute 11 here, then it will be 11 minus 2 into 11 minus, sorry, it will be 13. I'm sorry, this will be 13. So it will be 13. So here 13 minus 2 would be 11, and here 13 minus 12 would be 1. So again I'll be getting it 11. So that means n is equal to 13 is also one of the possible values for which the entire expression is a prime number. Fine. And for n is equal to 12 is equal to minus 1, we get the value of n to be 11. Right? So if I substitute the value of n to be 11, then it's going to be 11 minus 2 into 11 minus of 12, which will give me a negative value, right? So again we have to discard it. So we have got two values, and that is n is equal to 1 and n is equal to 13. For these two values, I am getting this expression to be a prime number. So answer for this question is 2, because we have been asked that for how many positive integer, and this is a prime number. I believe all of you have understood it, and I repeat, such questions have appeared very consistently both in mocks as well as in MBA entrance exams. And these are the best way, this is the best way to ensure that you get all the possible values. Do not ignore the negative values. ठीक है, यहाँ पे पॉजिटिव इंटीजर लिखा हुआ है, दैट डजंट मीन कि उसका फैक्टर नेगेटिव नहीं हो सकता. ठीक है गाइस, प्लीज रिस्पॉन्ड सो दैट आई कैन मूव टू द नेक्स्ट क्वेश्चन और द नेक्स्ट कॉन्सेप्ट. Okay, great. So these are some of the questions which have appeared very consistently from I would say the area of prime numbers. There are other questions also, but obviously you can go through the practice exercises there. That is also filled with video solutions. So you will find some other questions of a similar kind. So you can now apply the concept. Okay, let me move to the next thing. And the next thing which we have to understand is perfect square. So there are some properties of perfect squares, and those are very important. The importance is why, because if you don't know the properties of perfect square, there are certain kind of questions which you will never be able to attempt, right? Or you will be getting it wrong. So some of the properties of perfect square is that no perfect square ends with no perfect square ends with 2, 3, 7 or 8, right? So if I get any number, any big number whose unit digit is 2 or 3 or 7 or 8, then we can definitely say that that number will never be a perfect square. Again, the logic or the derivation have already been done in the video explanation. ठीक है, अभी मैं आप लोगों को सिर्फ बता रहा हूँ कि क्या प्रॉपर्टीज है. तो वो दैट प्रॉपर्टी यू हैव टू रिमेंबर दैट 2, 3, 7 और 8 से कोई भी परफेक्ट स्क्वायर एंड नहीं होता है. दिस इज द फर्स्ट प्रॉपर्टी, राइट? एंड ऑब्वियसली ऑड नंबर ऑफ जीरो से भी एंड नहीं होगा. फॉर एग्जाम्पल 100 इज अ परफेक्ट स्क्वायर, बट 1000 ending with 3 zeros will not be a perfect square, right? Now the other thing is that if the perfect square doesn't end with 2, 3, 7 or 8, so it can end with 0, it can end with 1, it can end with 4, it can end with say 6, in fact it can end with 5, it can end with 6 or it can end with 9, right? In number से perfect square end हो सकता है. So obviously if it ending with 0, then the 10th place digit has to be 0, right? And if it is ending with 1, then the 10th place digit has to be even number, and that is very important. ठीक है, उसको प्रूफ करने की जरूरत नहीं है. We can just plug some of the perfect square. For example, 81 is a perfect square, right? Now here we can say that it is ending with 1, so 10th place में digit is 8, which is even. You have to only look for even or odd. ठीक है, कोई एक भी एग्जाम्पल ले लिया तो जो होगा वो सारे परफेक्ट स्क्वायर एंडिंग विथ 1 के लिए होगा. ठीक है, फॉर एग्जाम्पल 441, दैट इज ऑल्सो a perfect square of 21, वो भी 4 से एंड 1 से एंड हो रहा है, बट द प्रीसीडिंग नंबर और प्रीसीडिंग डिजिट इज 4. सिमिलरली 121 ending with 1, so the number here is even, right? And for 4, the number just preceding 4 or the 10th place digit has to be even. ठीक है, जैसे 64, 144, again you can see that the 10th place digit has to be even. ठीक है, now the number which ends with 5, and if it has to be a perfect square, then the 10th place digit has to be 2. ठीक है, 35, 45 इन सबसे perfect square end नहीं होता. लास्ट में 25 होना चाहिए तो वो perfect square हो सकता है. Again, the converse is not true. What I mean to say that every number which ends with 25 does not necessarily a perfect square. But if a perfect square ends with 5, then the 10th place digit has to be 2. Similarly, for 6, the 10th place digit has to be odd, right? For example, 36, 16, in both the cases you can see that the 10th place digit is odd number. And for 9, the 10th place digit has to be an even number. Fine. So these are the things which you can just you don't have to memorize it. आप initial कुछ perfect square निकाल लो. You can just take any number. उसमें even होगा तो even रहेगा हमेशा के लिए, odd है तो odd रहेगा. Only for 25, only for 5, just remember that it should always end with, or it should always precede with 2. No other number or no other digits. Correct? No, so this was the second most important concept of perfect square. And third, which is very, very important, and that is the digit sum or digital sum, I would say. Digital sum of any perfect square has to be either 1, 4, 7 or 9. The digital sum of all perfect squares are either 1, 4, 7 or 9. I'll just take a couple of 1 minute. There is some problem with the system. Please wait for a minute. Okay, I'm back. Now, what is digital sum? That is very important to understand. Now, the digital sum is that whenever you come across some numbers, for example, if I take a number 1743, now we know that how to find sum of digit, right? So, if we want to find the sum of digit, then we add all the digits. So, यहाँ पे कितना आ जाएगा? 1 plus 7 is 8, 8 plus 4 is 12, 12 plus 3 is 15, right? So, the moment you get a number which is more than a digit, or two-digit number, or three-digit number, then again we have to get the sum of digit. So again I have to add 1 plus 5, and which comes out to be 6. So we have to terminate this sum till we reach a single digit number. Okay? So this 6 will be the digital sum of the number 1743. I hope this is also clear. So all perfect square, the digital sum is always 1, 4, 7 or 9. Okay, just a second. Wait, wait. Hello. तो सही है यहाँ पे. Am I still not audible? Guys, please respond. Am I audible? अभी आ रही है आवाज? ओके ओके, ठीक है ठीक है. ओके, let me repeat this part. ठीक है, ये पार्ट मैं रिपीट कर देता हूँ. Now what I mean to say is that the digital sum is nothing but, if I take any number, say I took a number, say 1743, right? So how to find digital sum? We know how to find the sum of digits. So very first thing what we have to do is that we have to add all the digits. That is the sum of digits. In this case, the sum of digits comes to be 15, which is a two-digit number. So what we have to do is that again we have to find the sum of digit. So if I take again sum of digit, then it comes out to be 6. Now this is the digital sum. Once this sum, the process of sum terminate into a single digit, then we say that this is a digital sum. So any perfect square, the digital sum is always 1, 4, 7 or 9. And in this case also you can check that for starting some perfect square, if I write, then it is 1, 4, उसके बाद फिर the next is 9, then 16, then 25, etc. So obviously these are the single digits, तो इनको छोड़ देते हैं. 1 plus 6, again you can say that this is 7, 2 plus 5, again this is 7. So you take any prime number, or sorry, any perfect square, say 121, again you'll find that the digital sum is 4. So the digital sum of perfect square is always one among these 4 numbers, and that is very very important concept, right guys? ठीक है. So there are other properties obviously, ठीक है, but these are the 3 very very important properties of perfect squares. Now let us take the question. Let's see that how many of you can solve it. Now this is a very standard question, I would say. अगर perfect square सीखना है तो ये question बनाना चाहिए. ये question का solution gives you the entire the logic behind applying the concept of perfect square, or why the properties of perfect square are important. Many of you might have taken this question previously also, but since this question is very very important, I deliberately take these questions in my live session to make the new student understand. Please take couple of minutes to solve this. Any answers, guys? Okay, if I'm not getting an answer, that means none of you have gone through such questions then. Because जिनको पता होता है वो फट से आंसर दे देते हैं. Anyway, let me just take a couple of minutes to explain my course. So those of you who have already enrolled, they might be knowing it, and for those people who are yet to enroll or have just enrolled, for them I'm explaining this part. So once you enroll, you'll find that this you'll come down to this particular this page, and here you can see the syllabus. So what I have done is that I have divided the entire quant into 5 different parts. These are number system, arithmetic, geometry, algebra, and modern maths. And here you can see that all the theory with solved example have been given. So each thing has been further divided into a very basic things, and from basic to advanced का एक level चलेगा उसमें, ठीक है? So you can see that these are the numbers का theory है पूरा अभी ये. And once you complete the theory, these are almost more than 50 or 60 lectures of theory only on numbers, and then you come to the practice exercise. So each practice exercise have somewhere from 5 to 10 questions, and those questions are in the form of test, right, without time limit. And after the test you can go to the video solutions. All the solutions are video, and you can see that there are 22 problem sets, and similarly there are arithmetic uske theory hai with solved examples. And then we have practice exercise similarly for geometry, all the possible concept, and in fact in geometry I have tried to give you the explanation of all the theorems also, and how to retain them and how to apply them, right? So those of you who are planning to do so, they can just go to the description, they can fill that form. I'll just open this particular course of mine for one particular or one day, where you can go and check each and everything, right? And then if you are satisfied, you can go ahead and purchase it. This is the package. Apart from that, there will be 35 more sessions which I'll be taking, live sessions, something like this, but that will not be on YouTube, it will be on VizIQ, and those sessions will be recorded and put into the in this portal only. And if you can go to the overview part, you will find that you can click this section, that is CAT online live session plan. So a window will appear जिसमें कि एक PDF है, you'll get all the plans, the entire plans, ठीक है, of the live sessions, and some of the FAQs I have already written. Still, if you have any queries etc., then you can definitely drop me a mail, or maybe you can call me. My number is available at that portal also, right? Okay, let me come down back to just a second. Okay, let me come back to this question. Guys, if you have any doubt, you can just ask me later on regarding my course. Okay, let's come to this question. Now it says that there are 1,000 lockers and 1,000 students in a school. The principal asks the first student to go to every locker and open it. Then he has second student who go to every second locker and close it. Third goes to every third locker, and if it is closed, he opens it. And if it is open, then he closes it. And similarly every other student does the same, ठीक है? और ये पूरा process complete होता है till 1,000 student तक. Then we have to find that how many lockers are open. Now this question can very well be solved by applying the concept of perfect square, जैसा मैंने बताया, ठीक है? For example, what we can say that if I take any locker number, say 10. So initially the first student he is going, so he will be touching locker number 10 also. In fact, the first student will go to all the lockers, right? And initially it was open, so let me check whether it was open or closed. So go to every locker and open it. So initially every locker was closed, right? Then only the first student goes and he opens. So if I want to find that who all student will go and operate locker number 10. So obviously one will always operate locker number 10. 2 will also operate locker number 10 because 10 is a multiple of 2, or I can say that 2 is a factor of 10. Again we can say that 3 will not operate 10, right? Student number 3 will not operate locker number 10. He will operate 3, 6, 9, then he will jump to 12, so on and so forth. Similarly, student number 4 will not operate, but student number 5 will operate. And then 6, 7, 8, 9 will not operate, student number 10 will operate it. So I can say that locker number 10 will be operated by these students, right? These 4 students. So we can say that one will go, initially it was closed, so one will go and it will open it. 2 will go, it will close it. 5 will go, it will again open it, and 10 will go and it will close it. So we can say that after this operation, if you only focus on locker number 10, then initially it was closed, and later also it will remain closed, right? Because it has been operated by 4 students, or I can say it has been operated by even number of students, right? But if I take any other number, say 16, this is a perfect square. So obviously all those student number which are factor of 16 will operate locker number 16, right? So it will be 1, then 2, then 4, then 8, then 16. So these are the students who will be operating locker number 16. So here we can say that initially it was closed. So first student number 1 will open it, second will close it, fourth will open it, 8 will close it, and 16 will open it. So we can say that at the end of the entire operation, locker number 16, the status of this locker will be open, right? And it has been asked that how many lockers are open. Now why it will remain open? Because 16 is a perfect square, and there is one more property obviously which I'll discuss when we discuss the factorization, etc., that the number of factors of perfect square is always odd, and vice versa, right? If the number of factors is odd for any number n, then I can say that n is a perfect square, and if the number is a perfect square, then the number of factor is odd. Those of you who have some confusion about क्या perfect factor वगैरह होता है, they can just hold for some couple of days. I'll be discussing factorization. Therein I'll explain in detail what do we mean by number of factors and how do we calculate. So whenever we come across perfect square, the number of factors is always odd, and these are the number of students who are nothing but the factor of that particular locker. So जिनके भी odd number of factors होंगे वो odd number of times operate हुए होंगे, and if the locker is operated odd number of times, then its status will change from closed to open. So what we have to do here is that we have to find that from 1 to 1000 how many numbers are perfect square, right guys? And these are very easy to understand, that 1 square hoga, then 2 square hoga, 4 square, so locker number 5 square, that is 25, so and so forth. So we can say that 31 square, what is 31 square? It is 961, right? So locker number 961 is a square of 31, or I can say that locker number 961 is a perfect square, so it will be operated odd number of times, so its status will be changed from closed to open. And 32 square is 1024, so it is beyond 1000. So we can say that the number of numbers which are perfect square from 1 to 1000 is 1, 2, 3, 4 till 31, right? So 31 would be the answer for this question. I believe that every one of you must have understood it. I'll just take a pause. Please let me know that if this thing is understood or not. Okay, great. ठीक. Okay, let's move to the next and the last question. So this is the last question of this session, although this was the very first session, so I do not want to take it too long. So from the next session, definitely those people who have enrolled, they have to go through the theory videos and some of the practice exercise, and then they have to sit for those sessions so that we can do more and more. We can take more and more quality questions without wasting time in giving you the time to attempt those questions there itself. For this question, I'll give you 2 minutes. Please let me know the answer. हितेश परफेक्ट स्क्वायर निकालिए आप 1 से लेके 1000 तक कितने परफेक्ट स्क्वायर हैं. तो 1 का स्क्वायर 1 होगा, फिर अगला परफेक्ट स्क्वायर 4 होगा ना, विच इज नथिंग बट 2 का स्क्वायर, राइट. द थर्ड विल बी 9 विच इज नथिंग बट 3 का स्क्वायर. ऐसा करते हुए 961, बट 961 इज 31 का स्क्वायर. So if you want to count those number, that is 1, 4, 9, 16, 25 till 961, these are nothing but what? The square of first and natural numbers, first 31 natural numbers. So the number of perfect square will be 31. और परफेक्ट स्क्वायर के डोर वाले ही उनका स्टेटस और लॉकर का स्टेटस चेंज होगा. Next session I'll take about divisibility and factors. So those are very important topics. Obviously this is also important, but in that I'll take a lot of subtopics within divisibility and factors. So those are going to be very helpful for solving many questions. Many times we have to use number system, not directly, but it is an intermediate steps to solve some of the complex questions from algebra. Okay guys, any answers for this? No one? Okay, one answer is 0. Fine, the right answer is 0, yes. 0, there will be no number which are formed by using these digits will be a perfect square. Those of you who have a fundamental idea about permutation and combination, if I want to find that how many 10 digit numbers we can form, then this is nothing but 10 factorial divided by 1 is used 1 time, 2 has been used 2 times, so it will be divided by 2 factorial, 3 will be used 3 times, so you have to divide it by 3 factorial, and 4 has been used 4 times, so it has to be divided by 4 factorial. It's going to be a very huge number. ठीक है, बहुत बड़ा नंबर होगा, बहुत सारे नंबर्स बन सकते हैं इसके, ठीक है. But we can say that all numbers, in fact none of these numbers will be perfect square. Now what is the logic we have to use? We have to use the logic of digital sum. एक लॉजिक बताया था डिजिटल सम का, that the digital sum of all the perfect squares are 1, 4, 7 or 9. Now there might be different types of numbers which we can form using these digits, right? But we can say that, for example, one of the number would be 1, 2, 2, 3, 3, 3, 4, 4, 4, 4, right? This is one of the number. Now if I want to find the digital sum of it, then we can say that this will be 1 plus 2, 3, 5, 5 plus we can take 9, उसके बाद फिर ये 16 ऐड कर देंगे तो नहीं सॉरी this is 5, 14, 14 and this 16, 30, right? Again we have to add them, so we'll be getting 3. Now the digital sum of this number is 3. So obviously if digital sum is not 1, 4, 7 or 9, then we can definitely say that the number is not a perfect square. So we can say that this number is not a perfect square. But any other number which we form, for example if I take 1 और 2 को मैं swap कर देता हूँ, so the number will be 2, 1, 2, 3, 3, 3, 4, 4, 4, 4. Although the number is different, but the total sum will come out to be 30. So again the digital sum will again come out to be 30. So all the possible number which you will form, every time the 1 has been used 1 time, 2 will be used 2 times, 3 will be used 3 times, 4 will be used 4 times. So and they have been arranged in all the possible order. But in all cases the digital sum will be 3. And we can say that in none of the case, or in fact in all the cases, since the digital sum is 3 and it is none of 1, 4, 7 or 9, so we can say that none of these numbers will be a perfect square. Or we can say that no number will be a perfect square. So obviously we have to give a numerical answer. So the numerical answer would be 0. Right guys, you can just see the kind of question which we can solve just by applying the the properties of numbers. That's why properties are important, because there are certain kind of question which will be thrown which can only be solved by applying the properties. We can't derive there, इसलिए properties जानना जरूरी है. ठीक है guys, any doubts please let me know, and please like and subscribe the channel, also share it. And if you want to access the Quant online course fully for full entire 24 hours, please go to the description, click the link and put your details there. We'll be activating your account in some time, maybe a couple of days. Am I not audible? Am I audible or not? Okay, great. So this was the very first session, guys. The other session has to will be of a longer duration, at least for 1.5 hours to 2 hours. But for that, obviously, you have to go through the videos first of all. You have to go through the practice exercise, so that you come and sit in the session with some kind of basic things already done, so that we can discuss some complex questions like this, which we have just seen in these some of these questions are related to question number, in fact question number 5, 6 and 7, right? So that's it from my end. And for any doubt and for any things you want to find, you want to ask, then this is my number. You can just ping me. This is my WhatsApp number. You can call me also. This is my WhatsApp number. Right? Thanks a lot for patiently hearing me, and good night. We'll meet on Wednesday. On Wednesday, I'll be taking the next session. Thank you.